So in this problem we have this flat wire that looks like this with a current I flowing in this direction. The width of this wire is W. It's infinitely thin, but it has some width W. And we want to know the magnetic field at this point P, that's a distance B away from the flat wire. So a cross-section of this flat wire would look like this, with the current flowing out of the page like that. So it's a very thin but flat wire. Point P is over here at some distance B away from the wire. And we want to know the magnetic field at point P. So if we draw a coordinate system like this with the x and y axis like that, we can say, well, this flat strip of wire is made up of many infinitely thin wires. And each of these infinitely thin wires produces a magnetic field at point P. The magnetic field of one of those wires is given by this expression. So it's pointing in the positive y direction. Well, because the current is flowing out of the page for each of these infinitely thin wires that make up the flat, thick wire. So the magnetic field at this point is pointing up. And d here is the distance between each of these infinitely thin wires and point P. So to calculate the total field, we have to use this concept of current density, where the current density is the total current through the flat, thick wire divided by the width. And now we have to sum up the contributions of all these infinitely thin wires. So the total magnetic field at point P is the integral of the fields produced by all these infinitely thin wires, where the current of each wire is just the current density times the thickness of that thin wire. And we integrate from x equals 0 to x equals w, which is the thickness of this wire. So now we just have to do this integral. It's very, very easy because the integral is just this term. Everything else is a constant that comes out of the integral. So now the integral of that, we know we can write it as this, where the integral becomes a natural log evaluated at the two limits of interest. And this just is equivalent to this term right here. So it's pointing in the positive y direction the way we drew our coordinate system. So here was our coordinate system like that. This was a wire, and the magnetic field at this point P is pointing upwards like that. That's the magnitude of the magnetic field.